So welcome back guys. In this module we will going to study the concept of broadcast domain and collision domain. So what exactly broadcast domain and collision domains are? Let us go through the definitions. A broadcast domain for a given host or machine X is the set of all machines in the subnet which shall receive the R broadcast message generated by machine X. So this is the definition of broadcast domain, right? So if the machine X generates an R broadcast message, then the set of all machines which will receive this R broadcast message comes under the broadcast domain of machine X. Then collision domain. A collision domain for a given host or machine X is the set of all machines in the subnet which suffers collision with X if they also choose to transmit frame at the same time, right? So we will try to understand the concept of broadcast domain and collision domain with the help of an example. So for a given host in the network, you can be asked to find the broadcast domain and collision domain, right? So here is the tip. While finding the broadcast domain is easy, right? Just follow the definition and you can always easily find the broadcast domain of a given host, right? And follow the below analogy to find the collision domain. So to find the collision domain, assume that the physical wire to which host machines are connected is like an electrical wire which carries electrical current, right? So if some hosts transmit a frame on the wire, so assume when some hosts transmit a frame on the wire, then assume that the wire carries current, right? And you will die if you touch it. That is, if you are some other host which is connected to same physical wire, and if you try to transmit your own frame on the wire, then assume you will die. Here you will die means you will face collision, right? So you can touch the wire only when it has no current, meaning that you can transmit your own frame only when no other host connected to the same physical wire is actually transmitting. So let us try to understand with the help of an example. But before going to an example, let us first understand that what exactly collision is and why does the collision happen. So suppose there are two machines, that is machine G and machine F, both are connected to the same physical wire. Now suppose machine G transmits its data on this physical wire. Now data is nothing but it is a sequence of bits. So let us suppose that the machine transmits bits 1010 on this physical wire. Now note that the physical layer of the TCP/IP stack actually converts this sequence of bits into high and low voltages. So high voltage means 1 and the low voltage means 0. So this 1010 bits actually transforms to the following sequence of high and low voltage. High voltage means 1, low voltage means 0. So you can see that these sequence of bits can be transformed into this sequence of variation in voltages. Now this voltage is detected by the machine F, and the physical layer of the machine F reconstruct the bits by analyzing the voltage levels on the physical wire. So when it sees the high voltage on the physical wire, it take it as bit 1, and if it sees the low voltage on the physical wire, it take it as the bit 0. So you can see that this sequence of variation in voltage helps the machine F to reconstruct the bit 1010. So this is how actually data transmission happens on a physical wire, right? Now going forward, now suppose the machine G transmits data on the wire. It means that it varies the voltage levels on the wire. Now at the same time, suppose machine F also decides to transmit its data on this physical wire. So it will also try to fluctuate the voltage levels of this physical wire. So here the red color shows the voltage levels that is produced by the machine F, right? So you can see that both of these voltages actually transpose over each other to actually produce nothing. So in other words, we can say that the data which is transmitted by the machine G on the physical wire and the data which is transmitted by the machine F on the physical wire actually superimpose over each other to actually produce a garbage. In other words, it causes data corruption. And this is called collision, right? So the end result of collision is nothing but it is a garbage sequence of voltage variations on the physical wire, which actually translates into bit sequence, which means nothing. So this is how collision happens at the level of electrical signals transmission over physical wire.